Hello everyone, welcome back to session 2 of potential chemistry. Right? In previous video we have discussed about compounds, addition compounds, types of addition compounds. Those are double salts and complex salts. Right? Double salts which loses their identity in aqueous solution, but complex salts which retain their identity in aqueous solution. Right? After that we define coordination compounds. Compounds in which central metal atom or ion bonded to fixed number of ions or molecules with a coordination bond are called as coordination compounds. Then types of complexes. Types of complexes. First one is simple cation, complex anion. Right. Second one complex cation, simple anion, neutral complex as well as complex cation as well as complex anion. Right. In this video we are going to discuss about a basic terms in coordination compounds. Right. First term is coordination entity. Coordination entity or sphere. Coordination entity or sphere which constitutes a central metal atom as well as ions or neutral molecules. Those two are bonded with the coordination bond. Those are called coordination entity or coordination sphere. Okay, which constitutes central metal atom or ion bounded to fixed number of ions or neutral molecules with coordination or coordinate bond. Okay, this coordination entity which is enclosed in square bracket and which is non-ionizable. Okay, examples are K4FeCN6. This is a coordination compound, right? Whatever written in square bracket is a coordination entity. Second example is cuprammonium sulfate. Ammonium sulfate. This is a coordination entity. Third example is nickel tetracarbonyl. Right? These are the examples for coordination entity or coordination sphere. If coordination entity carries negative charge, then it is called as an anionic complex. Anionic complex. If carries positive charge, if it carries positive charge, it is a cationic complex. It does not carry any charge, nothing but no charge, it is a neutral complex. It is a neutral complex. I have taken 3 basic examples. Okay, ಅಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ ಗಳನ್ನ ಅಷ್ಟು ಡೆಫಿನಿಷನ್ ಟರ್ಮ್ಸ್ ಅನ್ನ ಈ ಮೂರು ಕಾಂಪ್ಲೆಕ್ಸ್ ಇಟ್ಕೊಂಡು ನಾವು ಕಲಿಬಹುದು. ಕಾಂಪ್ಲಿಕೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಬೇಡ ಇಲ್ಲಿ. ಓಕೆ, ಫೆಮಿಲಿಯರ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಏನಿದೆ ಅದರಲ್ಲೇ ಎಲ್ಲಾ ಟರ್ಮ್ಸ್ ಅನ್ನು ಕಲ್ತ್ಕೊಂಡಿದ್ದೆ ಆದ್ರೆ ನೆಕ್ಸ್ಟ್ ಯಾವುದೇ ಎಕ್ಸಾಂಪಲ್ ಕೂಡ ನಮಗೆ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಸೊ ಲೆಟ್ಸ್ ಟೇಕ್ ದ ಸೇಮ್ 3 ಎಕ್ಸಾಂಪಲ್ಸ್. Into that, first one is potassium ferrocyanide. It is an anionic complex. How it is anionic complex? Just see here. When this compound is put into water, it undergoes dissociation. K4 FeCN6 undergo dissociation. It gives 4K plus and FeCN6 4 minus. What is the definition? Coordination entity which is enclosed in square bracket, right? Square bracket alli bardirodu coordination entity annodadre which carries negative charge, right? Hence this is an anionic complex. Take second example, that is cuprammonium sulfate. On dissociation of cuprammonium sulfate, it gives SO4 minus 2 and CuNH3 4 times, which carries a positive charge plus 2 charges. See here, whatever written in square bracket constituted by the central metal atom or ion and molecules are ions. This is called as a coordination entity which carries positive charge, hence it is a cationic complex, right? For the neutral complex, tetracarbonyl, nickel tetracarbonyl, right? So this is a coordination entity or coordination sphere. Second term is central metal atom or ion. Okay, in complex, in coordination entity, in coordination sphere, the metallic atom, metallic ion is called as a central metal atom or ion which is bounded to fixed number of ions or molecules, right? What is central metal atom or ion? It is a metallic atom or ion which is bounded to fixed number of ions or molecules. Where? In coordination entity. In coordination entity. Take examples. Take the same examples. First one is potassium ferrocyanide. Right? In this complex, Fe plus 2 ion is a central metal ion. In second example, cuprammonium sulfate. In this complex, Cu plus 2 is a central metal ion, right? In case of nickel tetracarbonyl, nickel atom, because it is not carrying any charge. This is an example for central metal atom, nickel tetracarbonyl, right? Central metal ion or atom which accepts a pair of electrons. pair of electrons. Why they are accepting pair of electrons? Because they are electron deficient species, right? Electron deficient species are seeking the electrons, right? Hence they are also called as electrophiles. Those which accept the pair of electrons are called Lewis acids. Lewis acids, right? Okay. Next term is ligands. What is meant by ligand? Ligand is an ion or it is a molecule which donate a pair of electrons to the central metal atom or ion. Or else we can define like this also. The ions are molecules which bound to the central metal atom or central metal ion in coordination entity. Those ions and molecules are called as an ligands. Then define it. It is an ion or molecules bound to central metal atom or ion in coordination entity. So how they are bonding to the central metal atom? They are donating pair of electrons. They are donating electron annodadre. Those are electron rich. Those are electron rich species. In chemistry, electron rich means they are seeking of positive charge, nothing but nucleophiles. They are nucleophiles. Why? Because they donating a pair of electrons. They donating pair of electrons, right? ಈಗ ಮಕ್ಕಳೇ ನಿಮಗೆ ಒಂದು ಐಡಿಯಾ ಬರ್ತಾ ಇದೆ ಏನು ಕೋಆರ್ಡಿನೇಷನ್ ಎಂಟಿಟಿ ಅನ್ನೋದಿದೆ ಆ ಕೋಆರ್ಡಿನೇಷನ್ ಎಂಟಿಟಿಲಿ ನಿಮಗೆ ಎರಡು ಟರ್ಮ್ಸ್ ಕಾಣಿಸ್ತಾ ಇದೆ one is a central metal atom or central metal ion which is bounded to the fixed number of ions or molecules, right? That metal atom is called as a central metal atom. Those ions and molecules are called as a ligand. Central metal atom ion and the ligands together written in square bracket, those are called as a coordination entity, right? Okay. Next, classification of ligands. Classification of ligands. Okay. Ligands can be classified on the basis of its charge and its denticity. On the basis of charge, if ligand carries positive charge, what it called, right? If ligand carries negative charge, if ligand carries or does not carry any charge, on the basis of that we can classify it as anionic ligand. Ligand which carries negative charge. And how to define it? Ligand carries negative charge. It is called as an anionic ligand. Examples for anionic ligands are Cl minus, right? Br minus oxalate C2O4 minus 2. Right? These are the examples for anionic ligand. If ligand carries positive charge, if ligand carries positive charge, that is called as cationic ligand. Cationic ligand. Examples for cationic ligands are NO plus nitrosonium ion, NH2, NH3 plus hydrogenium ion. If ligand carries no charge, those are neutral ligands. Neutral ligands. Examples are water molecule H2O, NH3, and well familiar examples are frequently used ಮಾಡತಕ್ಕಂತ example ಯಾವುದು? Ethylene diamine CH2 CH2 NH2 NH2. Name is ethylene diamine. In short, it is written as EN. Right? Ligands ಅಂತ ಹೇಳಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? They must donate pair of electrons. ಯಾರಿಗೆ? Central metal atom ಗೆ ಅಥವಾ ion ಗೆ. ಹೇಗೆ? By forming the coordinate bond. ಎಲ್ಲಿ? In the coordination entity. If that ligand carries negative charge, anionic ligand. If it is carries positive charge, cationic ligand. If it is no charge, neutral ligand. Right? Next type classification is on the basis of denticity. Then what is meant by denticity? Denticity, nothing but number of coordinate bond that can ligand form with central metal atom or ion. ಒಂದು ligand ಎಷ್ಟು coordination bond ಅನ್ನು formation ಮಾಡ್ತಾ ಇದೆ with central metal atom or ion. That number is called as an denticity. It is a number of coordinate bond that can ligand form यार जोते with central metal atom or ion. That number is called as an denticity. Right? On the basis of denticity, if ligand bound to central metal atom or ion through single donor atom, then that ligand is called as an monodentate ligand. If ligand bound to the central metal atom or ion through two donor atoms, that ligand is bidentate or didentate ligand. Okay, if more than two means several atoms, several donor atoms, it is called as an polydentate ligand. Right? Take example for monodentate ligand. Cl minus, right? Br minus, water molecule, NH3 molecules are the monodentate ligand. While coming to the didentate or bidentate ligand, oxalate COO minus bidentate ligand, or ethylene diamine CH2 NH2 because there are two donor atoms, nitrogen and the nitrogen. Didentate ligand. In oxalate, oxygen, didentate ligand. For the polydentate ligand, take one by one. First one is tridentate ligand. Okay, ಇದೆಲ್ಲ ಗೊತ್ತಾಗುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ. Tri 3, denticity 3. Okay, ಹಾಗಾದ್ರೆ ನಂಬರ್ ಆಫ್ ಡೋನರ್ ಆಟಮ್ಸ್ ಎಷ್ಟಿದೆ ಇದರಲ್ಲಿ? 3 ಇದೆ. ಸೊ ಹಾಗಾದ್ರೆ ಯಾವೆಲ್ಲ ನಂಬರ್ ಆಫ್ ಡೋನರ್ ಆಟಮ್ಸ್ ಅನ್ನೋದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ನೋಡೋದಾದ್ರೆ, ಟೇಕ್ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್. CH2 NH2 NH CH2 NH2. What are the donor atoms in this example? That is nitrogen. They donate a pair of electrons to the central metal ion, right? M plus cation. How many plus charges? It depends on the atom, right? So how many donor atoms? 3. Denticity is 3, right? Next, take example for tetradentate ligand. Right? Example is NH2 NH2. How many donor atoms? 4. What are those? Nitrogen is in a donor atoms, right? 1, 2, 3, 4. Yarigi to the central metal atom. Or ion. This is an example for tetradentate because there are 4 donor atoms are there. Next, take example for pentadentate ligand. Okay. What is the name of this compound? What is the name of this compound? Okay. Count the number of ethylene groups. How many number of ethylene groups? CH2 1. CH2 second ethylene group. Ethylene. Right? How many nitrogen atoms from the amino group? There are 3. Tri-amine. In short, it is written as diene. Okay. For this, how many ethylene groups? CH2 1, 2, 3. 3 ethylene groups. Hence, tri-ethylene. 4 amino groups. Tetra-amine. Right? In short, it is written as triene. For pentadentate ligand, structure ನೋಡ್ಲಿಕ್ಕೆ ಮಾತ್ರ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದೆ, ಬಟ್ ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕಾಗಲಿ ಬರೀಲಿಕ್ಕಾಗಲಿ ಏನು ಇಶ್ಯೂಸ್ ಇಲ್ಲ ಇದರಲ್ಲಿ. ಜಸ್ಟ್ ಯು ಆರ್ ವೆಲ್ ಫೆಮಿಲಿಯರ್ ವಿತ್ ದ ethylene groups, right? CH2 ethylene groups. Ethylene diamine NH2, right? NH2. This is an example for bidentate ligand, right? Just replace the hydrogen atoms which are bonded to the nitrogen by acetate CH2 COO minus, right? CH2COO minus. How many donor atoms? 1, 2, 3, 4. Next, one more hydrogen atom is replaced by CH2COO minus. How many? 5. Retain one hydrogen atom as it is, right? So this is an example for pentadentate ligand. How? Because it having a 5 donor atoms, denticity is 5, hence it is a pentadentate ligand. Then what is the name of this compound? Ethylene amino groups 2 diamine. How many acetate groups? 3 acetate groups. Triacetate. This is also written as, in short, EDTA. How many minus charges? 1, 2, 3. 3 minus charges. Why it is EDTA? See, ethylene diamine triacetate, right? Next, for hexadentate ligand. Hexadentate ligand. Remaining one hydrogen atom in ethylene diamine triacetate is replaced by one more acetate group, then we will get hexadentate ligand, that is CH2, N, CH2COO minus, CH2COO minus, N, CH2COO minus, and CH2COO minus. How many donor atoms? Just count. 1, 2, 3, 4, 5, 6. Donor atoms are 6. Denticity is 6. Hexadentate ligand. What is the name of the compound? Ethylene diamine. How many acetyl groups? 4. Tetraacetate. In short, it is written as EDTA 4 minus. 4 minus. See here. So these are the examples for ligands, right? In this video, what we have learned from the basic terms. First term is central metal atom or ion. Second term is coordination entity. Third term is ligand. Next is classification of ligands. What is meant by central metal atom or ion? It is a metallic atom or ion which is bounded to fixed number of ions or molecules with coordinate bond is called as a central metal atom or ion, right? In coordination entity. What is meant by coordination entity? Something is constituted by the central metal atom and ion, and the ligands are called as a coordination entity, right? If coordination entity carries negative charge, anionic complex. If it is carries positive charge, cationic complex. If it does not carry any charge, it is a neutral complex, right? Then what is meant by ligands? Ligands are the ions or molecules. They must donate a pair of electrons. To whom? To the central metal atom or ion, right? Those ions or molecules are called as ligands. Ligands electrons donate ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ they are rich in electrons. If it is not rich, there must be electron precise molecules, right? The electron rich species are called as nucleophiles as well as Lewis bases, right? So central metal atom ion is which accepts a pair of electrons, means it is deficient in electrons, hence it is an electrophile. Electrophiles also called as Lewis acids, right? Next, classification of ligands. Ligands can be classified on the basis of its charge as well as denticity. So first one is charge, the basis of charge. If ligand carries negative charge, anionic. If ligand carries positive charge, cationic. If ligand does not carry any charge, it is a neutral ligand, right? While coming to the denticity, what is meant by denticity? Denticity is a number of coordinate bonds that ligand can form with a central metal atom or ion in coordination entity, right? Or called as a denticity. If a ligand bound to a central metal atom or ion through a single donor atom, it is called as a monodentate ligand, right? If it is bonded to central metal atom or ion through the two donor atoms, it is a bidentate ligand. If it is three donor atoms, try more than three polydentate. And these are the examples for tri, tetra, as well as penta and hexadentate ligand, right? In next video, we continue with the ligands. Further, there are ligands are there, some more ligands are there. Those are amphidentate ligand, flexidentate ligand, bridged ligand, as well as chelating ligands. Discussion ಮಾಡಲಿಕ್ಕೆ ಇನ್ನೂ ligands ಅಲ್ಲಿ ತುಂಬಾ ಇದೆ. That we can discuss in next video, right?